Okay guys, how are you doing? Hope you all are doing well. Today's lesson is over inverse functions. Okay, so when we're talking about inverse functions, these are technically functions that undo each other. They're functions that undo each other. Okay, now what does that mean? Well, that means for a function of y or f of x, right? Those are the two things. Its inverse will be denoted as y inverse, or y to the negative 1, or f of inverse of x. And it's negative 1. That really just means it's the inverse. It's the opposite of it in another ways. I kind of like that we have inverse operations, multiplication, division, addition, subtraction, so forth and so on. Okay, so when we're looking for inverse functions, in order to do them, to find the inverse values given in a table, you simply switch the x and y values. In the table. Okay, so you'll notice here on this table, you see how we have the x values and the y values? Well, in this one, what's going to happen is I'm going to do my y inverse and my x. So I'm going to change all of these. These will become my y values, and these will become my x values when I make them in my new table. So my new x values and my y inverse values. Okay, my x values are going to be 2, 3, 4, 2, 7. See how I just took my y values and I made it my x? Okay, and then my y values are going to be my x values, so it's going to be negative 3, negative 1, 0, 4, and 6. Okay, notice how I switched this x, these x column was the original y column, and this new y column was the original x column, right? That's why we call it the inverse functions. Okay, so how can you tell from a table if a relation represents a function? Well, the simplest thing is that x does not repeat. X does not, or does not repeat. Okay, so does the original table represent a function? Okay, so we look at the original table. We look at my x values for the original table. Negative 3, negative 1, 0, 4, 6. Nothing repeats there, right? I didn't say any numbers over again. So the original table does represent a function. So that's a yes. Okay. Now look at the inverse function though. Let's see if anything repeats. 2, 3, 4, 2, 7. Well, if you heard me correctly, I said 2 twice. And since that x value repeats in the inverse function, that means the inverse function is not a function. Okay, you got to be careful, make sure that you watch out for that. Sometimes when equations are functions, their inverse may not be a function. Make sure you pay close attention that x does not repeat. That's the most important piece. Okay, so example 2, how to find inverses of the following ordered pairs. Really simple. Just like in the table, you switch the x and the y values. Okay, so here's my point, 2, comma 3, right? So I'm just going to switch it. 3, comma 2. And negative 5, comma 8. Well, that's going to be 8, comma negative 5. And then 7, 3 becomes 3, 7. And then negative 9, negative 6 becomes negative 6, positive 9. That's simple. Just switch them, right? Switch your values. Okay, so does the original list of pair represent a function? Look at the x's. X, x, x. Did any of those repeat? 2, negative 5, 7, 9. No, they didn't. So yes, it represents a function because the x doesn't repeat. Now let's look at the new x values for my inverse. I have 3, 8, 3, negative 6. Well, you heard me say 3 twice. That means x does repeat, so that means the inverse is not a function, or no, it's not a function. Okay, so that's how we look at a table, right? This is how we do inverses with table. This is how we do inverses with ordered pairs. Now we're going to do inverse with mapping, and mapping's a little bit difficult. I think mapping helps best when you create a table. So you have this mapping where the 0 goes to -1, the 0 goes to 0, and the 5 goes to 3. So you can do this several different ways. You can build a table, or you can list your ordered pairs. It's completely up to you. Okay, so I'm going to go ahead and list the table. Okay, my inputs X, my outputs Y, right? My input of 0 gives me a -1. I have an input of 0 that gives me 0. I have an input of 5 that gives me 3. Okay, so this is my original function. Okay, the original, you'll notice, is not a function, right? So our original is not a function. Okay, but now I'm going to do the inverse, right? So if I do the inverse, I create a table. Remember, this is going to be X, and we're going to say Y inverse, or Y to the -1, and I'm going to switch all of my X values and my Y values. So now my X values are going to be my Y values. So this becomes a -1, this becomes a 0, and this becomes a 3. And my Y value, my new Y values are 0, 0, 5. Okay, and you notice, is the inverse a function? So this is my inverse now. These are the numbers I'm dealing with. X values, -1, 0, 3. Nothing repeats. So that means, yes, it is a function. Okay, so sometimes it could be the complete opposites of each other. All right, so again, table, points, mapping, right? Okay, so now let's look at how we're going to do this when we start graphing functions. Okay, easiest thing you can do is when you're trying to graph these functions is to get your table, plot your points. And here there's several points on this graph that help us create this table. Okay, so I'm going to go ahead and start off with this point, which is -1, -2, -3, 1, 2, 3, 4, 5, 6, 7. So I got -3, -7, -2, -5. What is that? 0, -1, 1, 1, and 3. 1, 2, 3, 4, 5, 3, 5. Okay, so there's my graph, right? I got a couple of points. When I do my inverse, I just switch the X and Y values. Okay, so here, remember, basically what's going to happen, I'm going to put my Y values here, my X values here. Okay, so my Y value, -7, -5, -1, 1, 5. Okay, now I put my Y values in, -3, -2, 0, 1, 3. Okay, and I can plot my points. I can actually plot this graph given these points. So if I have -7, -3 on the X, so 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. Okay, and then -5, -2. Okay, and then -1, 0. Okay, and then 1, 1. Ooh, notice they intercept. And then 5, 3. And there's the inverse. Okay, awesome. All right, so now let's look again. Example number 5, sketch a parabola. Let's list our X and Y values. For our points, we got -3, 1, 2, 3, 4, 5. So -3, +5, -2, 0, 0, -3, 2, 0, and then 4, 1, 2, 3, 4, 5, 4, 5. Okay, again, when I switch it, my X and Y values, this is my original Y's, these are my original X. So Y is 5, 0, -3, 0, 5. And my new Y values are -3, -2, 0, 2, 4. Oh, 3, that should be 3, I apologize. that should be 3. That's not 4. I made a mistake there. I apologize. Hopefully you get that on the video and you see that. Okay, so let's graph these new points. 5, negative 3, so 2, 3, 4, 5, negative 3, 2, 3. 0, negative 2, 1, 2. Negative 3, 0, so 1, 2, 3, negative 3, 0, 0, 2. And then, what's that? 5, 4. And this graph looks like this. This is what we call a square root function. Okay. All right. Awesome. So that's that. That's the graphs and everything there. Just put some wording to what we're doing here. A function and its inverse are reflections of each other over the line y equals x. Y equals x. The inverse of a linear function is still a linear function, unless, of course, it's not a linear function, right? Or it's a vertical line. But I guess the inverse would make it a linear function. Okay, the inverse of a quadratic function, that's x squared, is what we call a square root function. Okay, that should make sense, I think. All right. And I think, let's see this. Use the graph of the function to draw the graph of its inverse. Okay, so basically you're plotting the points. That's the easiest thing to do. Let's say this is negative 5, 4. This is negative 4, 3. This is negative 3, 3. Negative 2, 2. And negative 1, 1. Okay. So first of all is the original function. Let's see the x repeats. Negative 5, 4, negative 4, negative 3, negative 2, negative 1. So is the original function? Yes. All right. Now, simple, I think, if we do a table, it makes things a lot easier. So I'm going to flip this point, negative 5, 4. Now it's going to become 4, negative 5. I'm kind of just going to make a table, right? I'm just flipping the points. And then negative 4, 3. So that becomes 3, negative 4. Flip this one, negative 3, 3. So that's 3, negative 3. And hopefully you see right there that it repeats. So this is not a function. The inverse is not. Okay. Now here we graph this. Y equals 2x minus 5. Simple, easy. I hope you can tell that yes, this is a function. It's a linear function. So 1, 2, 3, 4, 5. And then my slope is 2. So up 2, 1, 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. Okay, and I'm just going to plot a couple of those. We have first one, 0, negative 5. That's this point right here. And we have 1, 1, negative 3. Then we have 2, negative 1. Then we have 3, positive 1. And then we have 4, 3. Okay, and what you can do easily is look at your y values and see if any of those repeat for the inverse, right? Negative 3, negative 1, 1, 3. None of those repeat, so that means yes, its inverse will be a function. Because remember, when we do the inverses, our y's become the x values. So that's another way you can do this. Okay, hope this helps. Y'all have a good day.